Now let's see another example of homogeneous equation. Example 2. Solve the equation x cubed plus y cubed dx minus 3xy squared dy is equal to 0. The first thing you need to understand, solving this type of equation, you need to understand, looking at this expression here, x cubed plus y cubed dx minus 3x y squared dy. Now, if you look at this equation here is of this form, and that is why you see that we have dy dx is equal to function of y over x. Remember, the first thing we explained that you will be given a function, and that function is in this form, whereby you introduce a constant, and which is lambda f of x, function of x comma y, and we have this to be f of x comma y to be equal to lambda k x comma y. Now, for this case, you are having this, that dy dx is equal to f, a function of y over x, and which is in this form. So since it's of this type, what do? The first thing you do is to recollect of what this function tells. Now, let's see the first thing. We need to introduce, since it's of this function, f y over x. Now, recall that this y over x, note that this y over x is also equal to what? V, which we have here. And looking at this y over x is equal to v, it can also be said to be y is equal to vx. What did I do here? You cross multiply. Are you getting? So that is y is equal to vx. Y times 1, y, v times x, vx. And this holds what you have in this frame here. Now, you move further. We need this. I can now move forward to say, let y be equal to vx. Come on. Now, you look at this frame. Let's differentiate this frame here. Differentiating this frame, you have it to be, now see, y is equal to vx. Now, differentiating this, I have dy over dx, which is equal to, this is a product rule. Now, you keep this one constant, differentiate this respect to x. Differentiate this respect to x, you have 1. That is times 1 plus, when you have this, you have, keep this one constant, differentiate v respect to l, you have the v over the x, and this finally gives me the y over the x is equal to v times 1 v plus x dv over the x. So, and this is the new frame I have, but I would not conclude with this. I would move further to express this, that dy is equal to vx. Now, multiply all through, that is, multiply all through, you multiply all through by the x, and this simply means I have dy dx times the x, and you have v times the x plus x dv over the x times the x. So this cancels out, and this cancels out. I have dy is equal to v dx plus x dv, and that is all. I have this one, this one. So I have a new frame here, and this frame is also what I have here. So let y be equal to vx and dy be equal to v dx plus x dv. So those are the two important things we need to have in mind. So please, for this new question on homogeneous equation, you put this, let y be equal to vx, the y is equal to the x plus that is x dv. So with this, I can now solve my homogeneous equation. Now let's go back to the question. You have s cubed plus y cubed dx minus 3x y squared dy is equal to 0. Now, go back to the condition let y be equal to vx. Meaning that whenever I see y in this equation, I'm going to substitute that to be what? Vx. And whenever I see the y in this equation, I am going to express that to be v dx plus x dv. Let's take a look at what is this. So this is equal to s cubed plus, what is this? That's vx cubed dx minus 3x. Remember, this is a y. I have that to be vx square, and this is dy. I have that to be v dx plus x dv, and this is equal to 0. Now I move forward to express this expression. Let me say that is x cubed plus, open this, you have v cubed s cubed, which is this. You have vx minus 3x. Express this too. You have, open it, you have v square x square, then open bracket v dx plus x dv, all equal to 0. Now, with this expression, I have this. Now, this implies that I have this. You open this bracket, using dx to multiply. So I have s cubed dx plus v cubed s cubed dx minus, now I'm going to do the same. Use this to multiply this. I have 3x. Remember, this is x here. This is s squared. So this gives me s cubed v square. Then let me do that one after the other. Plus s dv is equal to 0. This implies that I have s cubed the x plus v cubed s cubed the x minus, now this will multiply this here. I mean, this guy here will multiply this, and this gives me what? This times this. I have 3 s cubed and this v cubed dx. The minus times plus will give me minus 3 x cubed x, and that gives me x raised to the power 4. Then v square dv is equal to 0. Thank you. Now the next thing I'm going to do, I'm going to simplify this. Now look at this expression. Look at this expression here. You have v square and this s cubed v cubed s cubed v cubed s cubed dx. So it means this can go down. That is, it can be well simplified. That is this minus this. Okay, that is this minus this, and it will give me, remember there's an invisible one here. Yeah, there's an invisible one here. So take one of all these from this, and I'll be having this expressed in this form: s cubed dx, then plus 1 minus 3, and that gives me minus 2 v cubed s cubed dx minus all this 3s raised to the power 4 v square dv is equal to 0. A lot of work to do. So